So hello everyone, and welcome to Zio Meetup San Francisco. It is my pleasure tonight to be co-presenting with Girish. We're going to have two presentations tonight. The first one is going to be by Girish on our Scala journey, which is a very fascinating story of how Capital One discovered and unlocked the power of functional Scala. And then I'm going to follow up that presentation with one on the Zio of the future, where I will talk a little bit about what Zio is, why would you want to use it, and where Zio is heading in the near future. So before we get started, I want to announce that we have a workshop giveaway. So Zyverge is running a whole bunch of workshops between now and the end of the year, ranging from functional data modeling, Scala 3 for Scala 2 developers, functional effects, advanced Zio, functional design, functional Scala fundamentals, and finally building web servers with Zio. And in order to promote this meetup tonight, what we decided to do was give away 3 of these workshops to people who showed up. So if you want to go to any of these workshops for free, we're going to select 3 winners. All you have to do is post talk screenshots either on LinkedIn or Twitter using the hashtags Capital One, Scala, and Zyverge. Use all 3. And then in the unlikely event that we missed that, then please email us your post at contact@zyverge.com, and we will choose winners tomorrow. So these workshops range from sort of like $1,000 value all the way on up to $2,000. So it's a great value, and we are definitely selecting 3 winners tomorrow. So if you want to enter, please just follow those instructions there on the right. All right, so this meetup is made possible today by Capital One. They are acting as sponsor and also providing Girish's talk tonight, who's generously introducing and kicking off this meetup with a talk on their Scala journey. And so I want to say a few brief words in recognition of our sponsor, Capital One. So first off, Capital One is well known for being first a technology company and second a bank, and that's unusual, because most banks are first a bank and then second or maybe third or maybe fourth technology companies. And Capital One has flipped that around. They are hiring right now, and in fact, they are hiring for functional Scala developers. So if you are super excited about functional programming, if you love to work with Scala, if you want to be on the cutting edge, then let me give you a few reasons why you might want to consider working for Capital One. Number one, they are building a very strategic, very important piece of their platform with 100% functional Scala. It's amazing to see any company do that at all, let alone a company as big and as well recognized in the world as Capital One. So the decision to go all in on FP and Scala, it's amazing and very rare. They're also rebuilding core banking platforms on cloud native stacks. Once a month on some Friday, they have a sort of invest in yourself month in which you're free to work on pet projects or learn some new stuff or maybe do some targeted training, which is, again, very remarkable. There's few companies out there that take the time to reinvest in their employees, and Capital One is one of those. Also, they have an internal boot camp, functional programming boot camp, in which they teach and advocate for functional programming inside Capital One, which is a great idea and a great way to grow that base of functional programmers. And also, I'm quite proud of this. So Zyverge, my company, we have 3 people on the inside in Capital One helping them work on some of these core initiatives with functional Scala. And that includes Adam Frazier and Kit Langton, and in the very near future, Alexander Ioffe, author of Quill. So if you get to work for them, you also get to work for some of these really very talented engineers who help build so many wonderful open source projects in the Scala ecosystem. And then finally, Capital One is one of, actually the only top 10 bank that is running 100% on the cloud. They don't have their own data centers. They don't have their own sort of legacy bare metal machines. They're all doing sort of next generation, very innovative stuff using existing cloud services. So if you would like to work for this amazing company doing great things, then please definitely stick around after the chat. DM me and I can send you more information on how to apply. Or you can check out scalajobs.com or .dev, where their current job openings are posted. All right, so with that said, I am going to go ahead and turn it over to Girish, who's going to be speaking about Capital One's journey in Scala. He is lead engineer there at Capital One, and I believe we met 2 years, no, actually it was before the pandemic. I don't know, 3 years ago, Girish? When did we meet? It was quite some time ago.
Thanks for the wonderful introduction, John. I'm Girish, and I am a lead engineer with Capital One. And I'm part of the Core Modernization group at Capital One. And currently, as John mentioned, we are working on a very strategically important piece for Capital One, which is part of the Core Modernization process. And we are currently using Scala for that development. To start with, we were predominantly a Java shop. So there were a few pockets in Capital One where we use Go for some of the work. And there are a few Python pieces, like especially in the machine learning domain. And we had a few Scala pieces, but those were in the Spark pieces. So as a predominantly Java shop, at least me personally didn't have any exposure to functional coding. Although there were some pieces that we worked on earlier where we used RxJava. And so there was some familiarity with the elegance of coding with maps and flat maps and zip. But that wasn't in a strongly functional programming sense of it. But we had some exposure to this magical world of coding using those kind of construct, although we didn't completely understand functional coding then. So as John mentioned, there's a lot of work happening in Capital One, strategically very, very important for us. Even the CEO talks of what we are doing all the time in a lot of strategy meetings. Fundamentally, what we are doing is our team is focused on developing a DSL, which can be used to describe the behavior of financial products. We are also building an interpreter that can interpret this DSL and make the financial products come alive, so that the lines of businesses can easily describe new variations to financial products. Now, although I'm saying that we are currently developing this DSL and this interpreter, we didn't start there. This realization that a DSL and an interpreter would be a very good design for our problem dawned on us over various POCs that we were working on. Initially, we started with a Go project where we were trying to play around with what we could do to solve our problems in our domain. Though that Go POC didn't turn out the way we wanted, we learned a lot doing those pieces of work and explorations, where we realized that what we wanted to do was to actually develop a DSL and an interpreter for it. We had a few really good Scala developers in our team, but because Capital One was predominantly Java shop, and when we said we have to use Scala, there was this initial resistance from especially the executive leadership that, okay, how would you hire talent for this? How would you grow this team? We have no skill sets on Scala. All these resistances we initially faced, but the problem at hand was so, what should I say, so much aligned to how functional coding and Scala would work, like the problem domain of describing a DSL, writing an interpreter. We're dealing with people's money, so correctness is of utmost importance. We realized in the Go POCs that immutability would be very useful for us. And we wanted to pick a strongly typed language. And Scala fit the bill. And the few experts, functional programming, Scala experts that we had on the team, from their prior experience, they quickly realized that Scala is the best choice for this. And we were able to convince the executive team that, like, let us go and start implementing this initial beginnings of this project in Scala. But as I mentioned, being a predominantly Java shop, we didn't have any knowledge of functional programming. And so then we started this journey of learning Scala. The obvious choice was we all went and signed up on Coursera Scala course, Martin Odensky's course. We completed it over a short while, and we got the basics. Like, we were able to start writing code in Scala. But again, we needed all these guardrails in place, because coming from this imperative world, right now jumping into this functional world was quite a steep learning curve. So we made this deliberate choice of using Scala initially as a better Java. We followed some just set rules for us, saying, okay, wherever you need these asynchronous constructs, we will use the future. So our many of our methods would return a future. We initially went with that for lesser learning curve. We stressed on using immutable data structures. We also made sure that we had included the what remover plugin in the build pipeline. Basically, we banned any use of statements, and we made sure that throwing an exception is a no-no. The plugin would flag it. All these steps were taken so that the journey from Scala to Java becomes more flat instead of being a very steep learning curve. As we progressed, we started implementing various structures, various parts of the DSL, the beginnings of, we chose to do, what is called double entry accounting. And to do all that, we were using the basics of Scala as long as we could. At one point, we realized that some kind of a library support would be, essential or necessary for us to proceed further. And the few people in the team who were experts in Scala, they suggested that we should, explore the cats library. We brought in cats into the mix, and cats, as you know, it's very powerful, but it has a steep learning curve. Our initial thought was that we would use cats based on the expert guidance. What I mean by that is we have a few people who understand cats quite well, so we would just follow their guidance. For example, if there is a construct like we are doing a try catch, then we would say in our PR reviews that, okay, cats has a construct where you could just do either that catch non-fatal, and those are the kind of guidelines we started following. But those days when we started, the IDE support for cats and complex functional constructs was not as good, to say the least. The compiler on the IDE would show in squigglies at the wrong places, and we would get thrown off. For example, I had a personal experience where there was this construct where I had to take a list of eithers, where the left is an error and right is some A. There could be some errors in this list. So I had to go through this list, figure out if there is at least one error. If there is one error, I am supposed to return a full left. Otherwise, I had to, do a right of a list. I didn't know anything about cats those days. So I just coded it up manually, doing, traversing the list and pattern matching and all that. And during the peer review, again, I got this comment saying, oh, this is just a traverse or sequence operation. You have to use this cats sequence. I started reading upon the cat sequence, signatures and what it means and all that. Figured out how to code for that. And when I started writing the code, there's so many squigglies. And because I'm new, I'm thinking I'm doing something wrong. And I spent hours trying to figure out what I'm doing wrong. And somebody suggested that why not just run SBT compile, and it worked. Spent 4 hours on a correct code, which the squigglies were throwing me off. And we had these experiences many times. And then the learning curve in that path was getting to be really steep. We thought we should encourage more people to share knowledge. Whoever has learned something about any aspect of cats should share the knowledge. So we started having these lunch and learns. Buy some pizza, sit around and talk about. We started talking about monoids and functors and monads and applicatives. Basically category theory based, trying to follow the manual of cats. But that turned out to be not a very good attempt at learning Scala. Again, the steep learning curve. The team felt that the practical applications or solving for the practical problems that you're seeing there, that's not happening by learning Scala this way. And obviously the concepts, the theoretical concepts, the team was struggling a lot with those concepts. Down the journey, slowly we had many epiphany moments. Like, for example, one experience that our team had was with refactoring. Now, coming from Java, the experience of refactoring in Java, my personal experience to quote again, whenever I used to refactor code that was written in Java, I would start like with a brainstorming session, like, yeah, this needs some kind of a refactor. Let's do this, let's do that. Discuss all the pros and cons and decide on an approach. Okay, we are going to do it this way. And then get to your desk, start making the code changes, get the Java code to compile. When you try to run the test would not compile. So you would make the necessary changes here and there and make the test to compile. And then when you run the test, more than half your test would fail. Then you need to spend time thinking, the code compiles correctly, but something that I've moved around has changed the meaning of it. Now try and find out why the meaning changed. And then you put the pieces together correctly, make one test pass, make the next one pass, and finally all your tests pass. And when all your tests pass, you're successfully refactored and you're confident that the refactoring is happening. And this has been my experience. And with this approach, I'm sitting in front of my Scala code, trying to refactor. Again, the same exercise. Make all the changes after all your deliberations. Then once the code gets compiling, when I try to run the test, few tests were not compiling. I got them to compile. And now I'm waiting for the test to fail. And all of them passed. Not one failed. And I was like, oh, this is interesting. And in those days, when the first time it happened, I didn't realize it's the power of Scala or referential transparency and immutability and all this together and good functional coding is helping us do that. I didn't realize it then. Now, hindsight is always 2020. I can understand that. But those days, I was really surprised. Oh, this is a good choice. Scala is a good choice for us. That's what I thought then. We hired external consultants to come over and look through our code because there were questions on, again, the choice of Scala and whether a team that is just learning Scala can handle something of this strategic importance. And when this review happened, the comments from the reviewers were like, yeah, you made a good use of Scala and CATS libraries. Your code quality is quite good. It's pretty good code. But the approach you are taking to teach Scala in your teams, that's way off. Nobody wants to learn Scala using category theory and monads and functors and the laws of functors. That's not the way you teach Scala. And when this person said that, it was like, oh yes, maybe that is what we were doing wrong. How to teach Scala. Then again, we started this journey on trying to find ways to teach Scala. Now we have a team. New people keep joining a team. Capital One has these TDP programs where fresh college graduates can come and join us. And when they join our team, we want them to be productive as quickly as possible. New hires, we want them to be productive. But we didn't have a mechanism or a methodology or approach to teach our code base and kind of Scala principles to new Scala developers. And so on this journey, like I was looking at YouTube videos or blogs or other CATS documentations to see whether there are pointers to teach it better. And I remember, in fact, it was one of the videos of John himself, which was titled FP to the max. There was this point in the video where John says, okay, you build a rudimentary effect system. John's example had a final case class IO of A, which takes a function that doesn't take any parameters and returns an A. And then he builds a map and a flat map on top of it. And then once that is there, he showed how you practically apply that thing to solve certain business scenarios. And I was like, yeah, maybe that is what we are missing. This good effect system that does all the work for us, and we just use it to solve our problems. And then we started the search for what could be a good effect system. And we hit upon Monix task. After a lot of evaluations, we agreed as a team to embrace Monix task. And immediately we kind of started realizing the benefits. The productivity of a team started improving quite drastically, and it became easy for us to teach other people. Not that we are teaching them the core theory behind functional programming, but we are just giving them guidelines that if you're doing an IO or intend to do a side effect in your code, like calling a database or writing to the log or printing to the console, anything that you want to do, make an envelope of task around it without even actually thinking through that, okay, what you're trying to do is creating these value objects that are descriptions of what you want to do. Now, these words that I'm just saying are, again, the hindsight being 2020. Those days, it was just this simple methodical or mechanical approach to surround things with tasks. And slowly, we started understanding functional coding and how it works. And now that our productivity had improved and also our progress on our ideas about the DSL and how account state would look like and all the internals of our project, when it matured, the code base actually grew quite complex. They were, as in when the design evolved, we had more than one components in the ecosystem of the things that we were building. And slowly we started seeing another kind of problem. Our build times started getting longer and longer. It would take, I don't know if I would remember correctly, it would almost take 45 minutes to 1 hour for our whole code to compile at one point. And at that point, we revisited our code base. We were quite comfortable working with SBT then. Our teams, various members in our teams were good experts on how SBT works and code modularization. They looked through the code and identified modules that had no dependencies on each other and restructured code and built parallel executions of the build pipeline. And at this point, we were also facing some issues. I don't recollect exactly what, but Ivy was causing some problems during the download of dependencies. And so we switched to Corsair in those times, and our build times also improved. And once we had a good build system, and we had a very stable build pipeline, and we started progressing again. And now currently we are a team of really good Scala developers. I can probably say that in our journey from people who knew nothing about functional coding to this point where we really appreciate the benefits of functional coding, we have a really enthusiastic bunch of people who are kind of encouraging people to do functional coding. We easily teach our new team members the concepts. The hand-holding is very smooth now. Quite more experience with Scala. We have done quite a few contributions to open source Scala projects. Like I clearly remember very recently, we had to integrate, I think it was open telemetry with Monix Kafka. And we found that was not happening because of some constructs in the within the Monix Kafka library. And our team made the changes to Monix Kafka and submitted a PR. And that got accepted. And we were able to integrate Monix Kafka with OpenTelemetry. And as John mentioned, we have a partnership with Zyverge these days, and really awesome people, Adam, Kate, and I think very soon Alex is joining us. And now we have a thriving community within Capital One where we discuss Scala. And I think every Thursday or alternate Thursdays, John and Kate have this very open session where everyone joins and we talk of something like just before this meetup, we were talking about variants and covariants, and everyone participates, and this liveliness of our Scala community is something I really enjoy. And we are currently preparing to migrate to the Zio library, and very soon we will be porting our all the code that we have written into Zio, and that's our current state of our Scala journey. Have any questions? Let me know. And as John mentioned, we are hiring, and that's it from me.
Thank you so much. So we do have some questions. We have one from Howard who says, how many years did it take this journey from Java developers to proficient functional Scala developers at Capital One?
So if I talk of my personal journey, this would be 4 years. For the last 4 years, I've been learning Scala, and currently I think I'm pretty comfortable with Scala. But if you talk of other people, like the new people who are coming in are learning much faster because we have understood how to teach Scala to new people. But I struggled a lot initially because we didn't know how to approach learning and teaching Scala.
All right, we may have other people asking questions. Let's see, but I had one for you. So when you were speaking, you spoke very fondly of the very subtle, I think, very maybe difficult to appreciate at first benefit of functional programming, which is you can refactor and your code still works, your test still works. So of all the sort of benefits that you got out of functional programming, was that the one that stood out the most?
For me personally, that was kind of a shocker when I first saw it. And I remember talking to another senior engineer, Leonard, about this, like, how does that happen? And he's one of the experts that I'm talking of. He comes from the Haskell world, building systems for, I think, aeroplanes and all. So he's very good at functional coding, and he explained to me like this local thinking. You write a function, you just look at it, all the meaning is right there. There is nothing that you have to keep track of globally. And that helps you think very clearly about your refactoring. And when you make these local changes, you're not somehow changing this global meaning of your code. So it's a combination of all these benefits of functional programming. One, fundamentally, the referential transparency that you have, you replace code, the meaning is not changing. And because nothing is mutable, you are not pulled under, nothing gets pulled under your feet without your knowledge. And so that gives you that confidence that you can. I'll tell you a story. Very recently, what happened? There was this problem that we were facing. I told you about the open telemetry integration that we did. And one other benefit of effect systems that we noticed was you take a fundamental effect, like say, I want to talk to this database, make this query. Now I want to retry. Now I want to retry with an exponential backoff. All this is like you take this fundamental construct and add on top, and everything works. So we did all that, but our retry wasn't working. Whenever we retry, you get another Kafka error, or I think it was an open telemetry error, which says the headers are logged. And it was confusing. What happens is we didn't realize that Kafka, which is a Java library, mutates the producer record that you send it in. And the next time when you use the same record, it wouldn't work. And we're like, oh, we were so blind to this old style of mutating code that we never saw that. And that was like another time when I realized that, okay, if you strictly make sure that you are writing with this principle of immutability, very, very strictly following that principle, it's great for your code. And one of the fundamental reasons why you can refactor is that immutability.
Yeah, that's tremendously powerful, I think. And it's a very practical reason to do FP, not necessarily just pure to be pure sake, but do purity so you can refactor your code without fear, without breaking your tests, to give you a handle on the complexity of your software. I think that's very compelling.
Yeah, and I remember you said this, I think, in one of our talks. Code, the life of the code, majority is the maintenance of the code. And if that maintenance part is easy, life is easy. And FP helps you with maintaining your code.
Yeah, that's absolutely correct. So we have a bunch more questions. One from Girish, which is, what was the best way to educate enterprise developers on Scala?
I would like to understand what that context is. Enterprise developers, what does that mean?
I assume enterprise Java developers, probably sort of classic enterprise trained Java developers.
So the current Java libraries, I think they have many functional constructs. Although Java doesn't strictly call itself as functional programming, there are quite a few constructs in there that may look familiar to functional programmers. But if you first, I think, is to get this idea of an effect system clear. Once you have that if you can make people understand that if you can create a value that describes your effect and then build everything on top of it, I think that would be the path of least resistance to come to functional coding. If you think of immutability, you could do immutability in Java too. If you think of I don't know, you can't pass functions around in Java right now. You could do that in Scala, but you can have the discipline of writing immutable code, writing pure functions, and carry that knowledge into Scala. And if you understand effect systems combined with that knowledge, I think that would be the path of least resistance.
All right, thank you. We have another question from Vijay, which is, which parts or frameworks from Java have you continued to use along with Scala or independently? What about Spring?
That's funny. One of our teammates, it seems, the first question when one of our teammates asked when we said we'll use Scala was, can we use Spring with Scala? We haven't used Spring in a long while, but there are quite a few Java libraries that we use underneath. Like, for example, Log4j. There are a lot of logging libraries that we still use. As I said, Kafka. Even though we use Monix Kafka, underneath, you still have the Java library. So these libraries make sure to kind of hide these, I shouldn't say ugly sides of the library, but the mutating pieces and all. So underneath, there are quite a few Java libraries that we still use. But what we do is we take a functional library on top of it and then use that library. For example, Monix Kafka. We directly interact with Monix Kafka, though Monix Kafka underneath interacts with the Kafka API, which is Java. If we can find a pure functional library for a use case, like for example, parsing JSON, we use Circe because that was a choice that, when we didn't know Scala, it was just a guideline saying, oh, that is the best library of choice. Why? Because it is pure functional. So we choose Circe that way. But there are quite a few libraries that we interact, which are still Java.
All right, thank you. We have another question, which I think a lot of developers will be interested in, and that is, this is from Sanjay. He says, thanks for the presentation, Girish. What are some of the arguments you use to convince management about using Scala for your project? A lot of developers would like to be able to successfully convince management to use Scala.
So that's a very intricate, involved question, I think. See, for us, the situation it's like the planets aligned for us. We were doing this POC in Go. We were trying to improve on our ability to deliver functional products, financial products faster. And our POCs indicated, like the learnings from the POC led us to this idea that, oh, this DSL is what we want. And at that point, now we wanted immutability. Why? Because our POC showed that mutating code is more difficult to maintain, and the correctness guarantees that comes with it and all is more difficult. And we used those understandings that we had. See, there's this enterprise push to do something. Our POCs indicated certain things, and the best approach that we found was the DSL and the interpreter. And that led to Scala. So I think the conviction, the convincing part has to, you need to have a very suitable project first that could really benefit. Now I'm really convinced that anything can benefit from it. But if you can find the benefits of correctness, of referential transparency, of strong typing, then you can propose Scala. Now, earlier, if you asked me, is it easy to learn Scala, I would have said no. But now I can say that it's actually very easy to learn and teach Scala, especially with modern libraries, especially Zio. We had a very recent experience. Like I just mentioned that we are planning to move to Zio. It's not something that we took lightly. Like I've been suggesting in various forums in our internal teams that Zio seems promising, but it wasn't an RC then. All the RC candidates, it's very difficult at a bank to say that, okay, we are going to do a strategically important product, but we'll use an RC library. Now we are in a better position. There's a 1.0 release. And when we were evaluating, we were looking at developer friendliness. The error messages that you get while you do something wrong, if it is helpful, then the productivity is much higher. So now I believe it's much easier choice. It's easy to convince, but I think you still need that fundamental, alignment of your project's requirements and its nature. and alignment with Scala. Because if it's just a REST API, which just you get in some input, you update a database, why Scala might be a bigger fight there, because you're so easily doing it in Java. A person who knows Spring might be able to do it in a week. Now, if you want to learn Scala and on top of it, understand all the functional concepts, you might take 8 weeks, and then definitely they'll question you, why Scala? But if the project is of a nature which is more aligned to like what we have, then the push to Scala would be, worthwhile.
So it sounds like maybe that case is easier to make if the problem domain is more complex
Yes.
and less straightforward.
Yes.
Makes sense. Another question from Harish, which is, what build tool did you finally use for Scala?
SBT. We've already all through been using SBT. The first version was, I think, 0.13 we started with. And now I think it's 1.4.6, I believe.
Okay. Another question, which is, what metrics did the consultants you brought in use to measure how well you were using Scala?
I actually don't remember the details. There was this huge report on, it had, I cannot recollect. Sorry.
All right, a question from Naveed, which is, what's your best advice to inspire non-functional developers to come on board with the powers of functional programming, especially those developers who think it's overly complicated and hard to understand?
I think it's once you get into functional coding, it's very difficult to go back. It's like addicting. But I don't know how to get that addiction in place. If you ask me, can you do something in Go or Java now? I'll be very reluctant. Like, oh my God, it's very difficult actually to code in Java and Go. It's much easier to code in functional. Your productivity is much higher. The lines of code are so terse. It might appear difficult to read if you're not familiar with it. But once you have that familiarity, that's the only kind of code you want to read.
Yeah, I agree with that for sure. Another follow-up question there is, how did you manage to justify to stakeholders the hardships of hiring Scala engineers? Because it's hard to hire Scala developers, right?
Yeah, it's been a problem, and it is a problem, and I think that's what led to this partnership with Zyverge. We are getting really awesome people who are coming in and helping us understand Scala better. Like I was telling you, this talk on variants, although I've heard it in many different flavors, Adam's flavor was so much more insightful. And it is difficult to hire Scala developers. Of course, I think the number of Scala developers is much less than number of Java developers. But meetups like this, libraries like Zio, a community forming around that, we should be the go-to platform or technology stack rather than any style of imperative coding. I hope we reach there.
We're trying. A lot of us are trying.
Yeah.
Question from Ralph, which is, for people coming from Java, the object-oriented paradigm with inheritance is sometimes a real blocker for people to feel comfortable with functional programming. Did all of your object-oriented programming engineers make the transition? And how did you help that happen?
Repeatedly stressing on ADTs. Like, if you think of object-oriented at the data modeling level, for me personally, it took a time to realize that, seal traits and, case classes that extend the seal traits are not the same as, extending objects. But once that hurdle is clear, then the data modeling pieces kind of will fall in place. And then comes the service and service inheritance and all these abstract methods in some super object, and all your services extend them. All that is pretty easily implementable with just pure functions. So I think you should separate your data modeling pieces from your service pieces and concentrate on data modeling first. That is something that we have learned in these 4 years. Simple things like email address of type string, that's a no-no. That realization comes when it comes. That's all I can say. But once you know that typing is very important, like we started using, exploring libraries like Refind, and very recently I was exploring opaque types in Scala 3. What they do is give you the correctness at the domain level. Once you get that right, the possibility of writing wrong code is minuscule, and that improves your code readability. So to do your data modeling, use seal traits and sum types and product types. And to build your services, use pure functions, and things would be good.
Yeah. Thank you for that. And another question from Jean-Luc, which is, what is the impact on productivity, quality of using Scala in functional programming?
You might assume I'm biased, but productivity is way higher if you use Scala and functional coding. I keep talking about refactoring. Refactoring is something that you have to do all through the life of code. As I was mentioning earlier, the life of a code doesn't end when it goes to production the first time. That's when it begins. It stays alive for 5 to 6 years, and you have to keep maintaining it. And that is itself the benefit of it. You will have no hesitation to pick up any critical piece of code, make your changes, and when it compiles, 99.99% of the time, if it is Scala, it is correct. It is still having the same semantics as the earlier piece. So that itself is the biggest productivity gain.
All right, a follow-up question from Jean-Luc, which is, what is the most common delay between story inception and customers using the new feature? So like the time between that user story is created and when it's actually shipped to production, what slows you down that's relevant, I guess, to Scala and functional programming?
I do not see anything specific to using Scala that is causing a delay in this area. The delays from inception of a story to delivery, if at all there is a delay, it could be a change in direction or a lack of clear requirement specification or something of that sort. It has never been the choice of Scala. In fact, Scala has always helped us go faster, I believe.
It's great. Question from Ralph, which is, have you established a strong practice of test-driven development? I'm sensing that from what you have said.
Yes, we have. Okay, if you're asking that, do we do the tests first? No, we don't. But we cannot have our code merged without a minimal code coverage, and that's taken care by the build pipelines within Capital One. And on top of it, there are many other checks like vulnerability checks, a lot of other checks that run on a code. We ourselves have a bunch of unit tests, integration tests, and performance tests that need to be run before our branch can be merged.
Okay, question from Russ, which is, I think I've heard this question before, actually. Have you had any resistance from management around the ability to find Scala engineers versus more widely available Java and JavaScript engineers?
Yeah, I did mention this. That was one of the key points of resistance. How do you hire the resources needed? How do you hire the people needed? It was difficult 4 years ago. It has gotten better now, and I believe it's going to get better and better. In fact, I think we are going to hire a new team in New York, which is going to be exclusively Scala developers.
Wow, that's awesome. That's really great that you're just able to do that now because the market's improved so much.
Yes.
Question from Stu. Hi, Girish. Thanks for sharing your story. How fast were you able to make build times after your refactor? And what did you identify as culprits aside from SBT module design?
There were some internal build infrastructure changes that we had to do. Most of the Java builds that were kind of automated builds. So we have these kind of machine shop that just gives us instances that run builds. And these were by default configured with like, I think 1 core and a minimal amount of memory. So we had to customize them. And that really improved. Our local builds, because we would run it on a Mac with more, quite a bit of cores and 16 gigs of RAM available, they would run faster. I think we got the builds from around 40-45 minutes to 7-8 minutes. That's the kind of changes we saw in some of our builds. And I'm just speaking from memory of conversations.
Question from White Tire, which is, how do you prevent, but I need a special case on a common core function without compromising code robustness, crashing unrelated branches and test code with unrelated core library function changes? So someone comes in and they want one change, one-off weird change. How do you prevent that from negatively affecting code quality? It sounds like is the question.
That seems like life for us. Every day that happens, and we have our build pipeline like a safety harness, and that's how it works. We have this automated pipelines that, like, we have this developer discipline too. Locally, you're supposed to make sure that the test coverage is there, and when you're running all your tests, they're passing, your integration tests are passing, your PR, the pull request when it is running in the infrastructure, there is no regression in your performance. There is peer reviews all through. We have a clear definition in a Jira board story saying what are we supposed to do. So this feature is reviewed and automatically tested. And we also have a bunch of property-based tests in our pipeline. So randomized test data is used to test all our code. And those safety harnesses help us confidently keep changing and adding new features. I'm not saying that we have never faced an issue, but that's not the norm. We most of the time make changes without problems.
Great. Frank has a question. Hi, Girish. Are you able to apply domain-driven design with your Zio projects?
I am not an expert on domain-driven design, so I may not be able to answer.
All right. The question from SQL Expert. How functionally pure are you? Do you use akka, and doesn't that break purity?
We do not use akka. We try to be, so our current thinking is that any of the components that we are building will have these shell structure. There's going to be this core that is going to be pure. There is inputs going in there and there's outputs coming out of it. We kind of try to make sure, or we kind of try to make it a practice to not even have log statements in there. the inputs are clear to us, and even the success and the error paths, we have a shape that tells us what is going in and what is coming out. And then surrounding this, there is this effectful shell, which actually interprets and does this effects like calling databases and reading from. And that's the structure we follow everywhere. And so I think almost all of our code, at least within our teams, is a good example of pure functional coding. And to your question, we do not use Akka, so I think that answers.
That's great to hear. All right, we have 4 more questions, I think. One is, curious to know for Capital One to invest in developer training and improvement. Is there a simple way to sum up the return on investment, basically for companies trying to decide, will this pay off and should we invest the time? And to go this route, how has the situation improved now in cost and development time? I think this question is basically, okay, it's obvious that Capital One cares about developers and invests in their personal development and growth. Is that actually paying off? How do you know it's paying off?
So if you're asking in terms of what is the cost factor and all that, I am not aware of all that. But my personal experience, and this is from what I've seen around me, the more you let our engineers develop themselves, the more they tend to stick with you. The attrition is much lower, I think, because of that. There's this culture of belongingness now. We always learn together, and we always, at least that's been my personal experience, that I feel like all our team is like an extended family, and that is the benefit, I think. Now, if you are asking of how much does it cost to let them do this on a Friday versus what if they are done, I do not know.
Yeah, I think that's a great point, though. If your developers can't learn with you, they'll learn without you.
They'll with someone else.
The next job.
Yes.
All right. So I asked if you had seen a change in the number of production issues since you adopted Scala. Actually, Alexander asked that.
The current work that we are doing is not yet in production. It is supposed to go to production third quarter or fourth quarter this year.
So the answer is you'll find out, right?
Yeah, we'll find out.
Another question, do you find you need fewer programmers to get the same amounts of work done using Functional Scala?
That's been my personal experience. In our case, when we started getting this visibility, we had to do more and more work, and so we had to get more and more people. But I really believe that using Scala, because your individual productivity is higher, you can achieve more with a smaller team. Definitely.
Great to hear. Another question, or rather a question from Frank. What would be a good way to gradually move a code base away from Akka Futures to Zio without a big bang rewrite?
How about you answering it? You do a better job than me. If you had asked me how to move from Monix task to Zio, we had actually arrived at this approach that there is an alias in Zio called task, which for all purposes would work exactly the same. But because I haven't worked with Akka much, I do not know the constructs. But in Zio, there has to be a from future, which kind of lets you do the scaffolding.
That's right. Another question, what is the shape of your functional error path? Do you use either try or something custom?
So in our current code base, which is based on Monix task, we also include the either T transformer. So it is always an either T of an E and an A. Now that we are migrating to Zio, we have this Zio of REA with an orthogonal exit channel for the more fatal kind of exceptions.
All right, thank you. Question from Nathan, have you released any open source projects or gotten involved in community contributions?
Yes, I did mention that we are currently contributing bits and pieces into open source products, especially when it is directly connected to our work. Capital One does have an open source policy. We are allowed to run open source projects. Capital One has released open source tools, a few of them, especially within the DevOps domain.
That's quite leading. There are a number of organizations who unfortunately don't allow their developers to contribute to open source projects in any way.
We can use our official resources to contribute to open source projects. There's an approval process, but.
Question from Phil, what made you look at Zio?
My personal story behind that was when I was looking at task and this consultant talked of, we didn't use monad errors. That was one of the comments within the external consultant's report about our code base. And so I started looking at this concept of error channels. And I was kind of not following the reason behind why FX systems do not have an error channel. And when I was researching, I found this video where John was talking of IO of EA. And I was like, yeah, see, that is similar to what I was thinking. And I started following and then talking about Zio. And there were other people in our teams who had parallelly, like independently hit upon Zio and said, okay, that looks promising. And so we started following the developments in Zio. Like every video that John would release or someone talks about Zio, we would watch. I would take time and watch these videos. And this awareness that Zio might be useful started growing in our teams. We had a training, I think John conducted a functional modeling training. And we spoke a little bit about Zio even then. And very recently, we seriously started evaluating Zio, the developer experience, once it crossed the RC into major version release. And we found that it is very IDE friendly. That was very important to us. Like freshers, when they come and the error messages that the compiler gives within the IDE without any major annoyances with these squigglies, it's key factor for us. And that's how we kind of seriously took a look at Zio. And right now we are in the process of migrating to Zio.
All right, fantastic. I think we've managed to get through all, it felt like 20 questions. I don't know exactly how many it was, but it was a lot of questions, really excellent questions from super engaged attendees. So thank you everyone for asking such amazing questions. And thank you, Girish, for taking the time to answer all of them, every last one of them. Appreciate that.
Thanks for your time. Thanks for everyone's time. And thanks for this opportunity to talk here.
Fantastic presentation. And I'll clap on behalf of everyone. I'm sure they would be clapping if they could.
Thank you.
Really amazing talk and really eye-opening to see such a big company really embrace Functional Scala. Thank you very much.
Thank you again. We are hiring, so send in all your requests.
Exactly. Go work for Capital One. After this talk, you have lots of reasons to do that.